Hello everyone, welcome to ECS 179 Gameplay Programming. Today we're going to be talking about code style and we're going to be talking about exercise 1. So code style, we're going to have a quick few slide presentation on why code style. We're going to show you our code style document, which I'm hoping we will revise substantially in the next couple of days. And then we will explain more about the command pattern, so the example we didn't get to last class, and then we'll talk a little bit more about exercise 1. All right, let's step in. Okay, great. Okay, the audio is working. Let me bring this closer to my face. I know the audio recording's been a little lower than it, the bias has been a little lower than I'd like. So I'm gonna try to get the mic closer to my face. And Kyle, could you lower the front light, please? Thank you. I think it's the closest one to the front. Thank you. All right. Code style. So what are style guides? Have you all used style guides before in any capacity? Yeah? We got some thumbs? We got some hands? No style guides. Well, we often associate these in at least the American education system with conventions for writing. Things like using the Oxford comma, when to use em-dashes, semicolon usage, word usage, format. All these are typically expressed in style guides for English. They are there to promote coherency and consistency in your text, to make it easier to communicate to other people or to express your arguments in intelligible ways. I know many of you have probably read some very interesting English. Have any of you had the experience of reading Bourdieu? Logic of Practice? Any of these like French philosophers or scholars that have their deep, dense prose translated to English? Well, if you do, you can understand why complicated structures can make it a little hard to read, even though they're expressing complicated things. So their style guide is to express the most complicated things we can express. Most of the time, you are not expressing that level of complexity. So smaller sentences, more defined to-the-point paragraph structures are the way to go for general communication. How many of you used a system like Grammarly? Or any of these like more fancy ML-based spell checkers? Right? Have you ever had one give you the grade level or complexity of your text? Right, so you can see there's some metrics we have on text complexity. Now, often they'll give you your text in a grade level. What grade level are you writing for? And it can be interesting, right? And who knows what they actually key on a lot of the times. But they give you some idea, some notion of how complex your code is and what your style situations are like. Are you giving a style that's too complex, and therefore it's elevating your grade level of your writing? So, having the right consistency, having the right conventions for your application, for what you're trying to program and create, is just as important as having that same writing style structure for, English prose. And a lot of times it's specific to genre, medium, or field. Style guides for poetry, while English poetry is still in English, is different than novels, is different than technical writing. Style guides are appropriate for particular communities. And there are a lot of style guides out there. Many of you may have seen the Associated Press style book. It's for news media. It's really comprehensive. I kept this one in here, rest in peace, the BuzzFeed style guide. BuzzFeed had a style guide. I imagine they're probably one of the only style guides that had listicle support. I'm not sure. There's the Chicago Manual of Style, and that's for commercial and academic publishing. And if any of you are, do we have any cognitive psych people in here? No crossovers? Okay. Often, I'll talk to those folks, there's the publication manual of the APA, the American Psychological Association. It is for a scientific writing. The MLA, this one's pretty famous. The Modern Language Association Style Guide is for the humanities writing, and it focuses on language and language expression. Have you used any of these before? Been exposed to them? Anyone? Are there any ones that I don't know about? Are there any like interesting ones like, I don't know, like in Mandarin or something that I don't know about? Any other language style guides that you all use from non-English speaking areas? Maybe not. I'd be interested to learn about those sometime if you know about them. Conscious style is an interesting one, consciousstyleguide.com, for being more conscious about your language and making sure your audience can connect with it. Thought it'd be interesting. There's the Microsoft Manual of Style for their technical writing and documentation, which is quite fascinating. There's the Handbook for Technical Writing for those of you writing technical reports, manuals, documentation for your code on GitHub, all sorts of stuff. And then there's the Elements of Style by William Strunk, a common text to William Strunk Jr., a common text to get into the style writing world. How many of you have gotten big chunks of red ink on your papers before? Yeah, I got a lot of these. My grammar was so better than so good. Now, what's happening here? Inch margins, making it centered, making sure you have your name in the right place, make sure there's a summary before an evaluation for a book review. It's a standard form. It's a way to configure what you are writing for communication for someone else for this particular type of publication, type of writing. This happens to be an MLA format. Now on the right here, this is JavaScript.info's coding style example. Notice some similarities? Where do you put what? How do you space things? Where do semicolons go? Because in JavaScript you don't actually need them, right? But you use them by convention and style. Do you put spaces between your arguments that are delineated by commas? Where do you leave empty lines? Do you put line breaks before the beginning curly brace or after? People have strong feelings about this one in particular. Right, so this is another level of style guide. And how you choose a style guide is you want to conform to the community's practices that you're writing code for. This is important in open source projects. This is important for working in larger teams. The more uniform your code is to others' code, the more the team will be able to absorb it. The more cohesive the entire unit of some creation of code from the entire team will be and be perceived. Here are some code style guides. Allman. I'm sure you've all seen Allman. Allman is what we use for C#. One of my favorites, KNR. You read KNR, the text? This is a common practice here, Kernighan and Ritchie. Oh, classic C here. You should pick up a copy of this. This is the guide on C. But it's where it established putting the left curly on the same line as, say, the conditional or the iterative construct or the function declaration. It's meant for compact text. It's also meant for kernel development. And the reason it was so compact to begin with, well, I guess, actually, does anyone know? Before I lay into it, does anyone know why they're compact forms and why this style guide has an 80-character line limit?
I guess now they would limit it.
Exactly. It was what VI could display. You know, you didn't have much screen real estate. There were very few characters you could put on the screen at any given time. So you wanted to make sure that your lines of code could fit within the horizontal boundaries of the screen, and you want as many lines of meaningful code as possible in the vertical boundary. Now, technology has advanced, and now we have a lot more screen real estate to work with, and you can dynamically change the size of your font. You can do automatic line breaks. There's all sorts of fun stuff that editors do for you now that we didn't have before. So that means maybe more verbose or more vertically spread types of code are actually easier to read, and you still get more information per glance. So this is why Ullman is now becoming resurgent compared to K&R. It's just easier to see a lot of times, easier to grok the shape, because we're pattern matching machines as humans. At least I do this. Maybe some of you do this as well. When I first look at a code, it's easy to like look at the different shape objects in it. And when you're looking at a class or a standard form, you can, at the high level, tell like, okay, here's where the variables are defined in the class, here's where the constructor is, and here's where all the member functions are. Just without like reading any of the text, just like far away seeing the shape of it. Ullman helps you see the shape of it. K&R conflates that shape a bit. All right, new. Has anyone used the new style? Yeah, it's popular on the new tools, right? New software, but I don't see too many people using it anymore. Whitesmiths. Is anyone using Horstman? No one likes hurting themselves, I guess. Whatever. That's like just painful. I don't know why. But then the Haskell style, right? So you know where the line breaks are. You know you get a fresh line every line break because the line breaks go at the beginning of the line. You know you're not messing that up. Pico. This is where you really condense the vertical space of your text. Ratliff. Lisp, but expressed in C. The Lisp style guide makes a lot more sense when you're actually writing functional programs. So here are a few links for you to potentially check out. Python coding style compliance with Stack Overflow. So there are a few well-sourced, peer-reviewed literature on style guides. A collaborative approach to developing style guides is interesting. So if you want to do one for your team, for your projects, here's a starter on how to do it. This was quite popular when screen real estate got bigger, when programming projects started getting bigger, in the 90s, and now that sort of information is sort of baked into our practice today. But it's good to see the meta. If you go to google.github.io, you can see all of Google's public style guides. I think it's very interesting. I like looking at various style guides for various languages. They're fun. New.org's code standards, LLVM's coding standards, which is becoming more and more useful all the time. Mozilla's style guide, and WebKit for the web programmers out there. And you can find this information. This is from Wikipedia's indentation style guide. There's several more of these on here. I just picked the close ones, the ones you may know, and then some wacky ones. Does anyone know which one Arnold C uses? Is this still Haskell? Oh yeah, programming languages. You got so much to look forward to. So past style guides. The next level of thing you can do with your code to provide that consistency, to provide that readability, to provide that ability for others to rapidly consume your code and integrate it in part of their project are things like code analysis. This includes things you think of like testing, unit testing, regression testing, security testing, that sort of thing. Also includes profiling and slicing. How many of you have used a profiler before? Yeah, in which class?
Just personal projects.
Personal projects? Yeah.
I was for 36C with John David.
Oh.
Like you have to beat his time.
Yeah. Nice. That must have been fun. Who else? I'm sorry. Someone else had a hand? Profiling? Yeah.
So like databases, because Bash can go once you get, so I was like, profiling databases.
There you go. There you go. Excellent. Profiling, they're interesting tools. So they show you where your code is spending time. So they stochastically sample as your code is running what it's doing, what the function stack is like, what function you're in, what lines you're in. And so it gives you an idea of where your time is going. There's also monitoring, which is a more comprehensive thing like profiling. So monitoring is sort of a live process that runs and sort of like looks at your code as it's being executed and gives you a deeper inspection. Now those are handy. Those are very performative things. Static analysis is also, to me, a very interesting set of techniques. Type systems are the entry-level static analysis tool. So if you ever typed in a prompt and IntelliSense or some autocomplete shows you the options of how to, let's say, complete the member function, or when you start typing a variable name, will give you all the variable names that sort of like match that string so far in your code. Well, a lot of that comes from type systems. That's how they get that information. We use this a lot in C# in Unity. So when you, let's say you have a vec3 and you put the name of the variable like myvec dot, and then it shows you all of the member variables and all of the member functions that you could put after that dot. That's IntelliSense, looking at your type system, looking at your classes, seeing what things are next in that hierarchy that you can then use in your code. Control flow. This one's interesting. Now you're getting into something that does a deeper analysis of your code. It looks at your code, how it is structured, how different classes are being called and different functions are being called from your code's entry point all the way through a run. And it'll show you how deep your class call stacks are. Do you have any runaway recursive conditions? Self-referential things that are hard, that the compiler doesn't pick up at compile time. It'll also show you code that can't even be ran. Somehow is impossible for your program to get to. And that's really handy when you think something's running and it never actually runs and you don't know why. Control flow can help you determine that. Model checking. Now we're getting into things that are a little more intense. So model checking treats your program as a state model and goes through and manipulates all of its parameters, can do all the permutations, can do input permutations and try to determine what sort of output do all the inputs map to. So when it does a more comprehensive set of permutations on input, then you can see more discreetly where your errors are, where your edge cases are. So this takes a long time, it's intense, it's a field of study. You'll often see this called static analysis of code. That happens quite a bit now. Something that I don't quite know how to fit in yet now is our AI-based tools. Putting your code into large language models and saying fix it, saying show me where the problems are, saying simplify my code into something better. There's all sorts of capabilities we have now that I think need to be categorized in this like code analysis, code style, code production sense. That I think we're just now like starting to get a handle of the possibilities on. Half the time I forget to turn off Copilot when I present in class, so it'll autocomplete into some wackiness when I want to show IntelliSense. But you can see it there. It'll tell you, it'll try to complete based off the statistical average of what other people have done, given similar code to yours, what should be next. That can be correct, it can be incorrect. I'm curious, how many of you have used these large language models in your code? If you use it in your editor, how have you used it?
I just use Copilot.
Copilot? So you start typing and then it'll give you like how to finish the line to the next few lines?
Yeah.
Do you ask it any questions? You'd be like, write this function for me? Use Copilot's progressive question and answering?
Sometimes like it just sees the function name and just types everything for you.
Yeah. Give it through sometime. That's always hilarious.
Really.
Yeah. Who else? Anyone used it in another way? If any of you put like, let's say, an assignment description in and ask it to make the code for you? I'm not going to send you SJC for answering this question. It's recorded, don't worry. I mean, I do that in my assignments, yeah.
I also sometimes look up documentation. Sometimes
Yeah.
End of the question.
It does. And show me how this is used. Like, give me an example. Like a dictionary will have an example on how to use a word. Well, if you find like some weird call in the memory allocation stack in C, and you're like, okay, what does this thing actually do? How do people use this thing? You could ask for examples. So there's lots of really interesting ways to make your code better with these large language models, and to have analysis be done on your code. It's a really important tool for programmers to know now. I don't know, like, I don't teach a lot of the lower division classes. I don't know, like, what you've been taught or how you've been told to treat these AI systems. I think a lot of classes treat them with a little trepidation, right? Is it a tool that makes you not learn what you should learn? Is it a tool for academic dishonesty? I mean, we're gonna have to come to grips with this thing. So just to be clear, I am okay with you using large language models in class, but you're also responsible for like learning the content. You're all adults. Make your own decisions on this. You're not hurting me if you don't learn the code. You're hurting yourself. But they are a tool in the world. Get familiar with them. When you get out into the world, everybody's going to be using them, right? Imagine the NBA without enhancements. All right, some practical things for Unity. We talked about play mode color tint. Okay, so has anyone been through the tutorials enough to explain the difference to me between edit mode and play mode in Unity? Can anyone describe that to me? Yeah.
Oh, play mode is when your script is running and you can see everything working in real time. And then also when you make any edits to make it in play mode, once you're out of play mode, the edits revert back to when the original set running.
Exactly. So to paraphrase for the recording, play mode is when you're actually running your game, not when you're editing, not when you're creating scripts. It's when you actually want to run the game through Unity with all the debugging and everything. So all of the editor values are updating live. You can change editor values yourself, and it'll affect the actual simulation, the actual game that's running. Now the problem with play tint mode is as soon as you turn off play mode, all the values revert back to what they were before you pressed play. Right? That's intentional, right? If you play a game and then everything moves around, and then you stop playing the game, and things like stay at the spot where you stopped the game at, that'd really be harmful for level design, puzzle design. Everything would be all scrambled. You have to reset it every time you played, right? So this is an intentional feature. It can also be a real bummer if you press play, forget you're in play mode, and you tweak a bunch of things to be exactly right, and then you're like, oh, I'm in play mode, and you press, you leave play mode, and then all the stuff reverts back to where you were before you made those changes. It happens to everybody. It'll happen to you. Even with play mode tint on, it's tough. So I encourage you to do play mode tint. I'll show you how to do that. Did you show it, Kyle, in your tutorial?
I did not change the tint in the tutorial, but I did mention it.
Okay, if I remember to do it when we have code up, I'll handle it. All right. And make sure to pick a color that provides contrast. So you want to be able to see the difference between not play mode and play mode, but you also want to be able to see the code. So this is why I use like that gold color, or I've used a nice purple color in the past. So it matches like the dark mode tint, so you can still see the text. The text has high contrast with that new tint. I've seen some people who like, and this could be a value to you. If you make the tint like really white or something, so it completely washes out the text, you won't be able to edit anything. You won't be able to read anything, right? So that could be a real hard break if you find yourself struggling with play mode versus not play mode. You could set your tint so it's almost impossible to do anything in play mode. Could be handy. All right, choose your editor. Visual Studio Community Edition, Visual Studio 2022. All these support automated style guides. All of these will format your code as far as line breaks and everything for you. They're actually really comprehensive tools. Maybe not as good as Eclipse, but still pretty good. That was supposed to be controversial. So they give you a lot of capabilities, a lot of out-of-the-box features. Visual Studio does static code analysis. You can also download plugins for things like Sonar Cube, or you can run your code through IntelliJ's C# static analysis tools. So this is often what I'll do in larger projects, is I'll take my code base and put it in several editors and use all of their analysis tools, because each one of them do something better than the others. And so you get a more comprehensive, multi-spectrum look at the quality of your code. Usually, I mean, you don't want to do that like all the time, but when you're reaching milestones or you think your code's ready to be static for a while, it's good to run these analysis tools, a suite of them. And the Visual Studio Code has access to a lot of these tools as well. You can actually integrate almost all of these static code analysis tools inside of Visual Studio Code, except for the ones that are proprietary, like the JetBrains stuff. And there's also the styled editor that you prefer. Some people really like Visual Studio. It's got a lot of really quality points to it. But some people like Emacs. Some people like VI. Some people don't like using the mouse when they're editing code. Right? Learn the hotkeys. Get good. So that is important to think of as well. Your personal style, the way you are proficient at writing code, it's important. Some people like really blasting out code so they don't like moving their hands a lot. Some people are very thoughtful and will really think about like each line of code they write. And so each line is well considered. It's less of a draft of the code than like a well-reasoned placement. So it's all about your particular style, your way of processing this information, your way of producing text and code. So I encourage you to think about this at a meta level, or at an examination of your own practice. That's how you become better, right? And if you want a real trip sometime, screen record while you're programming, and then watch it later. It's painful, but you'll learn a lot. All right, Visual Studio Code. That's the one I'll be primarily using in class. Probably because I have so many plugins that I really like, and Copilot's built in, all the fun stuff. So I'll be primarily using it until I need to use the debugger. The debugger is, to me, makes more sense and is more robust in Visual Studio than it is in Visual Studio Code. So your mileage may vary. We'll show off the debugger at some point soon. How many of you have used any of the tools yet? How many of you have hooked? How many of you have played with the Visual Studio 2022 editor with Unity so far? Yeah, a few people? I'm assuming a lot of people did while they were following the tutorials. All right, well, the time will come where you'll have to actually open and run code. Because you'll have an exercise due in a week from today. So I encourage you to get these tools running and going. If you're not, if you think you're going to be a little stuck and you're a little, like on the lower end of experience for the class, I would just use Visual Studio 2022. There's a lot of good documentation on it. Unity officially supports it. And you don't have to do any reconfiguring of the editor with Unity to get it to work. It just, out of the box, just goes. So I'd encourage you to do that. But for those of you who are a little more confident, who have larger code experience under your belt, customize as you will. All right. Any questions about that? That was sort of the slide content for the day. Anyone have any favorite editors outside of this class? Like, what are y'all using these days? Okay. 1, 2. Neovim?
Vim.
Oh no! Oh no! Anyone else have a preferred editor? Atom, Sublime, VS Code? Yeah. Which one? Notepad.exe. We're going for it. Yep.
I just like
Visual
Visual Studio.
Studio. Yeah. A lot of tooling there. It's great. Yes.
I use VS Code.
VS Code.
Pretty much everything.
Yeah. Yeah. Huh?
I used to use Atom, and then it died. So
I know. It's a shame too because it was open source. It used the Electron shell, which was really great. Yeah. At least that lineage, that type of editor, like Sublime kicked off like an editor type and then that went to Adam, which kicks Sublime's butt, and now Adam got his butt kicked by Visual Studio, that sort of thing. It's good. Like, becoming familiar with your tools in your practice is good program. Okay. And Kyle, whenever you're ready for attendance, feel free to. Okay. So let me get back to the browser here. So expect updates to this style guide. I'm not happy with it. I've never been super happy with the style guide information for class. It's basic, but it's also an amalgamation of two different style guides because we need the C# information with the Unity.net stuff, and we need the Unity information. Unity in the community has never settled on one style guide for folks to use. It's always been pretty hodgepodge. So we're forming one out of this. So while this guide is a little hodgepodge and there's like documents I want you to read and integrate, you can actually see the embodied version of the code style in the exercises. So the exercises themselves follow our code style guide, and I'm really hoping that either Kyle or I have the bandwidth within the next few days to take those examples and turn them into a more full style guide in this document in styleguides.md for you to use for the class. Right, so you can see things like, we do have some examples. So it is both style, it's both idiomatic in C# and in Unity to use Ullman style braces. Sorry for folks who like K&R, like me. This is the lay of the land. Locally typed variables. When the variable type is very clear, it's good to use var. When variable type is not clear, it's good to use the actual type. There's a nice blog post on Unity code standards, which are great. So things like, when do you use public fields and when do you not? How large should your classes be? What do you do with large methods? With some examples. So I encourage you to look this over, because a lot of this is classic style guide stuff, like how many spaces do you use, where do you use camel case versus Pascal case, but also we're asking you for more than that. We're also asking you to examine your peers' code for best practices. So here's some pitfalls to avoid: public fields, large classes, large methods, and then here's the Visual Studio style guide for .NET. Which is quite handy. For this class, we'll go over this a little more next class as well. I don't want to spend too much time on this today, but I'll go through a set of code and show you the style guide for it after you've had a chance to read this document. And we'll look at the style guide for the class in an examined way, as opposed to a doc that I give you way. Hopefully we'll have both soon. Okay. And did you send out the attendance form, Kyle? Thank you. Where is it at? Is it on Canvas announcement or? Okay. And is it also in the syllabus? It is not. Okay. All right. So just so you can see. Attendance, there we are. Okay, so Kyle was kind enough just to send this out. Let's get this all on one page here. All right, so here we have the Google form for attendance. We have the GitHub Classroom how to get started document, and we have the link to assignment 1, exercise 1. Yes.
There's like a space between this one side and like the set also included.
Oh, no, not the end. Kyle, looks like you may have clipped. Is that the back row you clipped? There's one here that has a part of a code from another on it.
I don't include
include the two. Okay.
If you have an ambiguous one, let us know. We're getting this rolling for this quarter, so we're getting the cutoff. Okay. Any questions before we launch into some code? Talk about the command pattern. Excellent. So we will be looking at, that's command pattern exercise. We'll be looking at one of the projects in the folder. We started looking at this the other day. We're going to be looking at command pattern example. So let me load this in Unity Hub. It went to a completely bad side of the world here. It somehow ended up in my home state of Indiana. Here we are. Also known as Narnia. All right, command pattern example, loading it up. Get rid of my face for a little bit. Oh my gosh, what did it do? Okay. Let me fix OBS. Here we go. So here's a command pattern example. We talked about the structure last time. It is a simple scene called sample scene. As a main camera, directional light in the player. The player is a transform, a capsule mesh filter, a mesh renderer to render said capsule mesh filter, a capsule collider, in case we want to do logical collision detection, and an input map script. So pretty simple as far as the Unity objects go. The meat of this project is in the scripts. So let's take a look. So the first thing we have here is the collection, or is the input map. Do I do that, or do I do the shoot command? Yeah, input map. I'll show you the code in just a moment. There we go. So here we are. We'll open up the input map script. So you'll say it'll open up Studio Code, Visual Studio Code, and we are here. See if I can get rid of the taskbar here. Okay, something must be pinging it, so it's not, okay, whatever. Oh, there we go. Excellent, excellent. So this script is a mono behavior. It's called input map. So this being a mono behavior means it can be used as a component in Unity. It is part of the Unity lifecycle. So you can place input map on top of an object. In this case, we want our player, our capsule player object, to take input. Private eye command fire 1, fire 2. This may look familiar. We had pirate commands and pirate worker commands this morning. Start. So this is the function that happens when your script is first loaded, first initialized, and put into Unity, put onto Unity object. What we have here, we can get rid of this. I kept this as an example. So when you're dealing with mono behaviors and scriptable objects in Unity, some basic ways of associating code with gameplay. You can't use new directly. Why can't you use new? Well, Unity manages your instances and your constructions for its own internal use and for efficiency, and to hook it into its own set of processes. So they forbid you from using new when you're using a mono behavior or a scriptable object. But you have ways of creating instances of these classes. In the case of scriptable object, you can use the scriptable object's static function called createInstance and use the generic capabilities to say which type of scriptable object you want to make. In this case, make a shoot command. And you'll call that function with no variables, no input, and that will create a new instance of the shoot command scriptable object. So we bind that to fire1, we bind that to fire2. Well, fire1 and fire2 are I commands. So what does this tell you? Yeah. Sorry? They have an execute, right? That's part of it. At a higher level, it means that, hey, both of those classes somehow speak the language of I command. And by convention, I in front of a class name means it is an interface. Can anyone explain to me what an interface is? Going back to your object-oriented programming? Anybody who hasn't maybe spoken yet? Can someone tell me what an interface is?
You can only use fields and methods defined.
Yeah, exactly. So it's a way of partially specifying what a class has to have. But why do we do this? What are interfaces good for? What role do they play in software creation, in our software engineering lives? Anyone else who hasn't spoken before? Just seeing if we can spread the love just a little bit, then I'll call on you. All right, go ahead.
Encapsulation and data hiding.
So that's basic object-oriented programming, which this is a part of. Encapsulation and data hiding are key aspects of it, but interfaces perform a more particular role than that. Yes? Ding, 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 decoupling. Well done, well said. So this is a way for you to break hard links, to break associations between one bit of code and another bit of code. So notice here, we're not putting in shoot command, fire1, shoot, there are I commands instead of shoot command and collection nova command. Right, now we have this point of decoupling. Now fire1 and fire2 can be bound to anything that happens to implement the I command interface. Doesn't matter what it is, as long as it binds to that interface and has an execute function, as we'll see in a moment, it's a valid thing to put in fire1 or fire2. So that means it can be, it can be pay respects, it can be enact, it can be shoot, it can be reload. As long as it's an I command, you can put it there. So this is a natural point of decoupling between one part of code and another part of code. And decoupling is one of those key concepts that comes up time and time again in software engineering. Decoupling helps reduce the complexity of your code, makes it easier to understand, makes there be a way for you to hand your code off to someone else, and they don't have to worry about its complexities. They just have to worry about that one interface and doing that one interface properly. A larger version of this is like API calls, right? So like, TensorFlow, Facebook, whatever you got, whatever large scale API, X, send it off, it does a thing, does something complicated in the back end, and sends you back a result. The contract that you have with that API is calling it with the correct data and sending it over the line, and then knowing what you get back. Right? Everything else that happens in between those 2 points is sort of inconsequential to you. It takes time, but it's not something you have to worry about the details of unless there's an error. So this is what decoupling gets us. We don't care what fire1 and fire2 do as long as they have an execute function, as far as this input map class is concerned. Okay, so here we are. Fire1, execute, passes the game object. So let's look at the guts of this. So here is the I command. It's a very simple interface. We put it in our namespace command pattern because that's the name of our example. I encourage you to use namespaces to make sure your code does not conflict with other people's codes. I command is a public interface, meaning it's not protected. Any class can use this, can inherit or can implement this interface, and you can execute. It has an execute function that takes a game object. So this is all it says. anything, if you want something to be an iCommand interface, to implement the iCommand interface, it must have an execute function that takes the game object and returns void. Well, here we are, with Fire 1 being shoot and Fire 2 being collection Nova. This code compiles and works, so we know those interfaces are valid. Let's take a look at shoot command. All right. So shoot command takes a projectile, or it has a projectile prefab. So we're going to shoot something a lot. This is the thing we're going to shoot. So we have a projectile prefab to look at right away. This prefab is in the prefabs folder. Here it is. Just a bulletish thing. So we load that in here on enable. We load that prefab, so we have a reference to it, just like we had a reference to the growth objects in the procedural generated content tree example we looked at the other day. And so execute. This is the function that makes the command go. Execute the command. So we have 5 lines of code here. The first one is we're making a new instance of that prefab. Taking a projectile prefab, and we're spawning it at our game object, us, the thing that the player. We're spawning that projectile at our position with our rotation. Right, so we're just making it relative to us, to the player object, to this. Then we're getting its rigid body. Why would you want to get the rigid body of something? Yeah?
You want to modify its physics.
Exactly. Like, let's say you want to add velocity to something so it shoots. So here we're interacting with the physics system and giving it momentum, giving it velocity, giving it motive power. Or imbuing it with motive power. Pushing it, shoving it. This is different than if you don't use a physics system, you have to manually change, you have to model that sort of physics yourself, that movement yourself. You have to give it a speed and check the time and see how much of increment of speed this frame needs to move the object, to match the speed for output purposes, to make it look like it's moving in a constant or physics-like arc. So we're taking that rigid body from the projectile, and we're setting its velocity method, which has a get and set function, so it means it can take a vector 3. And so what we're doing is we are using the handy-dandy attribute, or handy-dandy method of transform forward. So no matter what its rotation, what its scale is, where it's placed in the world, it sort of like knows where its forward direction is. So we're making it go forward. So it has a forward vector, which is a vector 3. We're in 3-dimensional space, so it's forward is a 3-dimensional vector. And we're randomizing a value times a speed factor. So we have the speed factor of 50 here. So 50 unity units, or 50 velocity units per second, times, or I guess we have 50 velocity units times a value, a random value, 0 to 1. So it can just fall straight to the ground, or it can shoot off really fast at full 50 speed factor. So it'll either be between 0 and 50 inclusive. And then we are doing a little bit of fun stuff with it. We're changing its local scale, so we're shrinking it or growing it in 3 random values. Yes?
What is multiplying by the forward value?
It's a direction. Like if you want to give it speed, you need to give it a direction that you're shoving it in, right? And so we just want to shove it forward. And in this case, forward, I believe, is just 0, 0, 1. 0 in the x, 0 in the y, and z is forward. I think is in this case. I'll have to look at the coordinate system again. Yeah, Kyle?
Something to add. In this particular example, and I did the same thing in my tutorial on Friday, the way that you're moving this object here, the velocity, you are not multiplying by time dot delta time to normalize things. And that's because, and I didn't mention this in my tutorial, and I wish I had, because the physics system works on its own clock, different from the main ecosystem.
Yeah, so that's one of the handy things of having a built-in physics system is you could just give something some force, and then the physics system will just take it from there. And that's what we're using here. We'll look at other examples later where we will manually handle physics. Exercise 2 will have a lot of this, where you'll have to use like the fractional accounting of a second between last frame times the speed you want to go per second, and then manually move or translate an object forward to match that speed over time. So we'll go over that, but that's a great thing to point out. Thank you, Kyle. And then finally, we're getting the renderer from the projectile, and we're shedding its material color property to a new random RBG value. So we're randomly scaling it in X, Y, and Z, and we're randomly giving an RBG value, red, green, blue, not Ruth Bader Ginsburg, RGB value. So changing its scale and changing its color. So all these are going to be a little different. They're going to move at a randomized speed, have a randomized scale in X, Y, and Z, and have a randomized color. So that's a shoot command. Let's take a look at it. Get out of the projectile mode, or projectile unscale, free aspect, play maximized. Shoot. Oh. So this is happening once per frame, right? If you hold down the mouse, it goes, bah! And it's just utterly ridiculous, right? You'll never see Skittles the same way again. All right, so let's do this on play focused. Now I want you to take a look at the hierarchy over here on the side. Each one of these game objects are being added to the scene and tracked. Each of these are a new prefab instance, a clone of the projectile prefab. So we have plenty of them now. And so far we have no code to make them go away. So they will persist forever. But that's actually a feature of this demo. Okay, so that was shoot. So far we've had input map, where we have fire 1, fire 2. We just looked at the shoot command, which follows the iCommand interface. So we can put it in here. We have update here, which makes sure like it detects when we press fire 1 and calls execute on fire 1. It looks to see when we press fire 2 and presses execute for the fire 2 bound iCommand. We've seen the iCommand interface, which says, hey, this is the contract to be an iCommand. You have to have it execute with a game object. And then we have the shoot command, which we just looked at, which generates new instances of that projectile prefab. The last one we want to look at is my favorite one, the collection nova. What happened here? Get out of here. Oh, right. So we're using command pattern. I forgot to mention this last time. The command pattern means we've loaded this namespace, which means we have iCommand interface, part of the command pattern. We have shoot command. All of these are part of that namespace, so we have access to it, just like when using, you're including any other library of code you've written. All right, so this is the collection nova scriptable object, which also implements the iCommand interface. So, can someone tell me about inheritance in C#? I'm obviously inheriting a class, so that works, right? Okay, so how many of you, and no shame here, are comfortable with inheritance in object-oriented programming? How many of you think you may need a reviewer in object-oriented programming at some point soon? Okay, so we may need to do that. Okay, so basically, we are inheriting scriptable object. That is our base class that we're using. C# has mono inheritance, meaning you can only inherit from one class. There is not multiple inheritance like some newer programming languages have. This is to avoid the deadly diamond or a circular inheritance pattern where you can be your own grandpa, or essentially, right? So we can't munge up the tree, the inheritance tree. It is a tree, it cannot be a cycle. So to solve this, the easy way to do it is to only be able to inherit one class at a time. But we have two things here. You can inherit one class, but you can have as many interfaces as you would like associated with class. So here, the first one of these, if it is a class and not an interface, will be the thing inherited. You don't have to have one here. You could just have iCommand potentially, and it would treat that as an interface. It would look at it and be like, hey, the first thing here is an interface. That means there should be no inheritance here. It's only implementing interfaces. So inheritance, then implementing interfaces. That's sort of the order here. And it happens at the very top of the class declaration. All right, so we have execute. Now something we're getting here is projectile list. So this is using a Unity function called find game objects with tag. So if you notice inside of our, get out of here. Okay. In our projectile, notice the tag property here says projectile. So, pardon me, through your tutorials, you may have ran into tagging in Unity. We'll use this quite a bit. It's a handy thing to help categorize what types of game objects you have. In games, you usually have categories like wall, enemies, power-ups, things that are categorically different from other things and are treated differently in the game world. Those are great things to put tags on, right? So you tag things in your world and treat them based on those tags, based off those tags. And one thing you can do is, hey, Unity, find me everything in the scene that is a game object that has the tag projectile. So we're getting everything that has a projectile tag, all those clones of projectile that we made, all of those are being collected in a list. We really don't know what it returns here. Let's see. I guess it returns an array. I'm assuming it's an array list. It's not specified. I imagine we go to the documentation to find out exactly what structure it is. What's important about it is that it is an iterable construct that we can dump in a for loop and go through, which is exactly what we're doing. So for each projectile in our projectile list, we're setting its transform to be a new vector 3. So a random value, so between 0 and 1 times 5 minus 2.5, 1.5, so it's going a little up. And its z value is also 5 minus 2.5. I won't explain what's exactly going on in this. I want to see if you can divine this yourself. And then we are giving it a random velocity. And we're doing that for each thing in the projectile list. Any thoughts on what's going to happen here? Yeah, 1 then 2.
Explode.
Yeah, explosion.
Basically, we're gonna take all the projectiles we fired and then put them in like between 0 and 5 units around you, and a little above, and then it'll get them all random.
Exactly. Let's take a look. Play maximized. So I'm going to fire a bunch of these. That was fire 1. Now fire 2. I'm going to release fire 2. Nova. More. Nova. Right, so you can see a game where you fire a bunch of projectiles. Maybe you're a necromancer and you're shooting out a bunch of bone spikes everywhere and they're lodged in the ground. And then your cool move that's on a cooldown is Nova, right? Where they all are summoned and fly over your head in this bone storm, right? And then on their way to your bone storm, on the way to your Nova, they damage things on the way, and then you release it for massive damage all around everywhere, right? You could easily see this being in an action RPG, right? I think this would actually be really fun, like League or something. You have, dot things on the ground, and then your skill shot would be pulling them back and doing double damage by shooting it out again. This could be a really a fun mechanic. And here's a simple way to implement it. You could add this to your game. Now, these game objects, they're not going anywhere. We're just building a bunch of them. And then we're going to collect them all on a list. And we're going to iterate through that list. And once more, that execute command is called once a frame. So we're going to go through this list and randomly position everything, all of these, every frame. So it's going to be slow. Because I don't know how many, probably I have hundreds of game objects at this point, right? So why this is particularly slow is all of them have colliders. So they're all physically interacting with each other. And the more you have, the more impactful those physics collisions will be. So when I let this go, they're going to fly out very far. Maybe. If it catches. There we go. Right, so the more that they collide with each other, the more they add force with each other, the further they'll explode. And I am cheating a little bit. I did, this was a more hastily constructed example. So let's play focused. Okay, so what we'll see is, let's look at it from the top. Get out of here, animation. Why are you here? Hide. So we're seeing the game object from the top, right? So when I do the nova here, oops, let's move back a little further. I see the nova in there. Notice that they're not gathered in a circle. It kind of looks like a circle from the side. They're actually gathered in a square, just based off the physics we did. I didn't go through and do like a polar accounting for positions of these. So they're basically being randomized and placed in squares. So those kind of fun things you can do. You can get extra views and inspect your code by running game mode in the editor at the same time. And so you get a better view of what's going on in your game. All right. Any questions about this? Should I show you how to do tint mode real quick? All right. Edit. Preferences. Let's see, colors. And then tint mode is a color, when you can pick it with a color picker. The gold version's nice. Whoops, I did the color picker. So the gold version, it's one I use pretty often. I've used the purple one in the past. This one works pretty well. Some people like green. You can enter the matrix. But I'm a champion. I'm going for the gold today. Any other questions about this? Did you pick up some Unity tips today? I'm doing some code in front of you in class and going through projects with you to get you an idea of what these structures are like, how to build things, how to think about things. I'm giving you language to talk about creating things in Unity. And I'm trying to give you some more meatier code examples to dig in, because you're not, lower division students. You're all seniors for the most part. I imagine some maybe not seniors have crept in by this point, I hope, given that the wait list is diminishing. But let me know if you find this stuff valuable. It's worked out well in classes in the past, but I'm always looking to refine. All right, any questions? Yes?
Not really related to the class topic, but will you be having comments on it?
Yes, I'm going to be sending out, I'll put a message on Discord you can vote on. I'll either have them on Mondays or Fridays, and they'll probably be right before lunch. My schedule's a little impacted this quarter. It's been so hard to find the time, but I have to do it. I have to do it this week. So regardless of whether it's going to be persistently Monday or Friday, I'll probably have office hours this Friday, just as a stopgap. All right, please log on to GitHub Classroom. Please get your accounts in order. Get started. It'll take a while to get these things bootstrapped and loaded. If you have any questions on the command pattern or assignment 1, first line of defense is Discord. Post them there so everyone can benefit from your question, and we'll take it from there.
So, can you specify the due date for exercise 1?
It is a week from today. It will be at 11:59 p.m. next Tuesday.
Okay, thank you.
You're welcome. All right, I'm one moment while I stop the recording. Goodbye, everyone.